NASA's twin ESCAPADE spacecraft have finally launched. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. After weather delays, a government shutdown, and even a powerful solar storm, NASA's ESCAPADE mission finally began its journey to Mars on November 13th, 2025. The twin spacecraft will study how the solar wind interacts with the Martian atmosphere and its patchy magnetic fields. That's key to understanding how Mars lost so much of its atmosphere over time. Today, we're celebrating this achievement with two conversations. First, we're joined by Ari Koeppel, AAAS Science and Technology Policy Fellow and Space Policy Intern at the Planetary Society. He was at Cape Canaveral for the pre-launch events. He'll share what it was like to navigate multiple scrubs and a solar storm delay to watch the second ever Blue Origin New Glenn rocket launch, and feel that deeply personal experience of watching a spacecraft carrying an instrument he worked on begin its journey to another world. Then we'll learn more from Rob Lillis, ESCAPADE Principal Investigator and Associate Director for Planetary Science at UC Berkeley's Space Science Laboratory. He'll walk us through the mission's science goals, its unusual trajectory, and how two small spacecraft working together can map the dynamic interactions between Mars's very strange magnetic fields and the solar wind. And later in What's Up, Bruce Betts, the chief scientist at the Planetary Society, joins me to talk about why Mars still produces aurora, even though it doesn't have a global magnetic dynamo. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. ESCAPADE is short for Escape and Plasma Acceleration and Dynamics Explorers. It's a pair of identical spacecraft built to study how the solar wind interacts with Mars's patchy magnetic fields, and how that process drives the loss of its atmosphere over time. It's a small mission with a really ambitious goal, mapping Mars's space environment from two vantage points at the same time, and coordinating with other spacecraft to learn even more. To talk about the events leading up to the launch, I'm joined by Dr. Ari Koeppel, a AAAS Science and Technology Policy Fellow and Space Policy Intern here at the Planetary Society. Hey, Ari, welcome back to DC.
Hi, Sarah. Great to be back on the ground here in DC and also to be back on the show with you.
Well, you got to be on site for all the meetings and the events leading up to this ESCAPADE launch. I understand you didn't actually get to see it in person because of all the delays, but what were some of the events that you got to attend and what was the atmosphere with the people there?
Yeah, so just a bit of background. I actually have been involved in this mission for probably going on 4 or 5 years now. I originally got involved in this mission as a graduate student, working on the development of an instrument called the Visions camera, which is really the only imaging tool aboard the ESCAPADE mission. My involvement with the project has largely been through my involvement with the Visions camera team. And so leading up to this event, I had been working with the science team and the Visions camera team, making sure that everything was in order. There was a lot of anxiety. Is our camera mounted on the correct spot on the spacecraft? Is our camera going to turn on when the spacecraft turns on? And then also, are the conditions for launch going to be suitable? We really didn't know whether the launch was actually going to happen in this short time window, which is basically early November. We didn't know until about 2 weeks ago. And that's when they did the static fire test on the New Glenn rocket. What that test does is it basically tells us the rocket is firing normally and it's ready to go. And we're going to aim for that nominal launch window. The original time window was the afternoon of November 9th. So that's when everyone basically booked their tickets, booked their travel, and the official viewing party was set at this bar and grill called Fish Lips Bar and Grill. It's kind of a funny name. And the reason they picked that is it's a big venue where they could throw this this viewing party in a festive environment that overlooks the launch site just across the inlet that separates Cape Canaveral town from Kennedy Space Center, which is on the other side of the inlet. And it's actually, it turns out, a better viewing spot than the Blue Origin factory, which has this whole viewing platform, but is obscured by a forest in between. And so because there's no forest in between Fish Lips and the launch pad 36, we had this clear view of the launch pad. The atmosphere was festive, but at the same time, there were these scattered storms moving through the area. And so everyone's looking to the horizon, wondering, all right, is that storm going to move through the path of the launch site? There's all these overhead screens typically used for watching sports games. But in this case, they were streaming various streams relevant to the space launch, Blue Origin's official launch, Spaceflight Now's official launch viewing, and then also like weather radars. So everyone's watching the weather radar. All right, is this storm track gonna move across the launch site? It seemed like we were gonna actually make it happen on that first go around. And then a cruise ship moved in front of the launch path.
No.
and blocked out that opportunity. And then there were some other technical difficulties, it sounds like, at the launch pad. They had some issues with the mechanisms that hold down the rocket. And the result is that first launch was scrubbed. They set another launch date for the 11th. And early in the morning of the 11th, that launch was called off because it turns out, ironically, a probe going out to measure high energy particles from the sun is delayed by the largest solar storm of 2025, which happened to hit the night of the 10th and through the 11th. So then the launch was delayed to the 13th. I had to fly back on the 12th, so I did not actually get to see the launch. But in the meantime, between arriving on the 7th and leaving on the 12th, I got to go to the official launch viewing at Fish Lips, go to a bunch of happy hours with the mission team, commiserate over our anxieties over whether this thing was going to launch and whether the spacecraft was actually going to power up, and talk about the future of science at Mars.
I tell you, if all of the local restaurants and bars showed space launches on all the screens like they do with sports teams, I'd probably get out of the house more. It sounds like so much fun. But also definitely anxiety producing. There's so many firsts about this mission. So far, every mission launching within the SIMPLEx program hasn't gone according to plan. It's the first time we have a science mission launching on a Blue Origin New Glenn rocket. Also the timing with the launch. We'll get into that a little later in the episode, but I've seen the New Glenn rocket in pieces on the Blue Origin factory floor. I went to go see it during the first attempt at the Artemis 1 launch, which I also didn't get to see because I had to leave, right? But I can't imagine how impressive this thing must be in person. What was it like actually getting to see that thing?
That rocket was massive. I think it's an amazing piece of engineering. Not only is it a multi-stage rocket, but it also has this ability to land itself on this landing pad that they call Jacqueline, which is a floating barge at sea. And it does that through a series of articulated engines that move back and forth and can move it not only up and down, but sideways. And then it has these kind of landing legs that come out as it's approaching its final landing target. It's funny, the Blue Origin team was so ecstatic that this project actually worked. They had made one attempt before to land the first stage of the rocket, and it ultimately wasn't successful. And so this was actually the first success for them to be able to land the New Glenn, or NG-2, the second edition of this rocket.
Yeah, it's always so anxiety producing in the beginning. And then ultimately you hit that point where it's, you're just absolutely ecstatic that everything seems to be going to plan. And thankfully, I'm really glad, not just for the mission, but also for you as someone who got to work on one of the instruments that this actually went according to plan, because I know the heartbreak of so many people that work with us at the Planetary Society that have been working on some of these missions that didn't go according to plan. But can you tell us a little bit more about the imaging systems on board that you've been working on?
Yeah, so this is a really unique collaboration between NASA and Northern Arizona University. This is an instrument called the Visions camera, and it is unique because it's funded under an entirely new model for NASA. It's actually basically a ride-along for this mission. It was funded entirely by the university's funds, which is an interesting concept for the future of NASA missions. There's been a lot of talk about reducing costs of missions, whether universities can uptake it. I tend to think this is actually a pretty unique circumstance and not necessarily a long-term model for this type of development, but it is one that turned out pretty well in this situation. The university basically was given this opportunity to develop a component of the mission that wouldn't have otherwise been on the mission, but one that was really important for making sure that this mission has some public visibility beyond just the initial launch. And what I mean by that is that this is primarily a heliophysics mission, a mission with a bunch of instruments that measure things that are pretty hard for the general public to conceptualize, like high energy particles, the movement of ions from the in and out of the atmosphere of Mars, how the magnetosphere of Mars interacts with solar wind or particles coming from the sun. These are all things that answer important science questions about Mars. They tell us how Mars might have lost its atmosphere through time, which is something that is really important for understanding habitability on Mars. We think some 4 to 3.5 billion years ago, Mars likely had a surface environment that was pretty similar to Earth's. Sometime around 3.5 billion years ago, its atmosphere got wiped away by solar wind because its magnetosphere declined. We still don't know exactly why that occurred or how that actually took form. And so the primary goals of the ESCAPADE mission are to answer those questions. But there's not a lot of information you can show in press releases from a mission that's measuring things like that. One thing you can show in press releases are pictures. And so I was part of this team as a grad student developing these cameras through a student organized program at Northern Arizona University, where we had a set of student-led teams as well as professional advisors from professors and research scientists to build these space-ready cameras that could ride along the two ESCAPADE probes, blue and gold, and not only take pretty pictures, perhaps even take pictures of one another because it's two probes. We can maybe look at one another, but also do like a little bit of science. And my role on the team was actually as the science team lead, meaning I was coming up with the actual science questions that we might be able to answer with some cameras. And in particular, because this is a heliophysics mission measuring high energy particles, and also relevant to some recent events here on Earth, we're interested in seeing if we can try to track the auroras on Mars. And so in tandem with these high-tech, high-energy particle instruments that are measuring solar wind and its interaction with Mars's magnetic field, we now have these cameras that are mounted on the two ESCAPADE probes that can potentially actually see the green glow of the aurora. And so we can pair those things in tandem. And so whenever that phenomena occurs, we'll now have the opportunity to put out a press release that says, not only did we detect these with the 3 major instrument packages that are measuring solar wind and high energy particles, but we also took a picture that you can see with your 2 plain eyes. And we're really excited about the opportunity to do that. And we're excited that we were able to kind of institute this unique partnership as a ride along with the mission.
I'm sure it means so much to you and so many of the other grad students and other students in general that have been able to work on this kind of thing. If I had that opportunity at university, I would have lost my mind. It would have felt so great to be a part of that. And I say it time and again, but putting cameras on missions for communications purposes, it's so important. And I know in my heart, one of these days, we're going to get back one of those images from Mars with the Aurora. And I would love to see the look on your face the first time you get to see those pictures.
Yes, I would be even more ecstatic than the actual launch would be getting usable data back that's showing us the wonders of Mars and the broader universe.
Well, I'm sorry you didn't get to see that launch in person, but it sounds like you had a wonderful adventure and many adventures to come when this thing finally gets to Mars, or when it slingshots around the Earth to try to get out to Mars. There's still several steps along the way. But thank you so much for sharing part of the story with us and for going on this awesome adventure and reporting back.
Yeah, thank you, Sarah. It's been fun to follow along with this mission after kind of my involvement in engineering the instrument has come to an end, and hopefully we'll get some images back soon that we can share with the broader world.
Fingers crossed.
Yeah.
Thanks, Ari.
All right. Thanks, Sarah.
Good news for Ari and the Visions camera team. On November 21st, the camera that's aboard ESCAPADE Gold captured its first light view, which was looking across the spacecraft solar panels. I'll put a link to that image on the webpage for this episode if you want to look at it. Now, if you've been listening to Planetary Radio for a while, you might remember that Dr. Rob Lillis has been on here before. Back in 2021, he joined my predecessor, Matt Kaplan, for an episode called An Escapade to Mars, on the cheap. That was back when this mission was still mostly a bold idea. Send 2 orbiters to Mars for a fraction of the price of a traditional flagship mission. ESCAPADE is part of NASA's SIMPLEx program, which stands for Small Innovative Missions for Planetary Exploration. It was created to test whether small, relatively low-cost spacecraft could do serious planetary science work by accepting more risk and leaning heavily on commercial partners. There have been other SIMPLEx missions that have launched, but all of them have run into major problems after reaching space. ESCAPADE is actually the first to make it cleanly through launch and early operations, and to begin a healthy cruise phase. The mission is led by the Space Science Laboratory at UC Berkeley, which is where Rob is based. They worked with Rocket Lab on the twin ESCAPADE spacecraft called Blue and Gold, named for the UC Berkeley colors, and it was built on the company's Photon bus. A set of partners supplied a bunch of the instruments, which you'll hear more about in a little bit. At some point, ESCAPADE lost its original rideshare opportunity, so the mission team had to completely rethink how to get it to Mars. After launch, the spacecraft is going to detour to the Earth-Sun Lagrange point 2 for about a year. Then, once Earth and Mars align better, the spacecraft is going to loop back toward Earth and then use Earth's gravity to slingshot towards Mars using an Oberth maneuver. It'll take a little bit to get there, but once Blue and Gold actually arrive at Mars, they'll start out in similar elongated orbits before they finally drift apart, giving scientists 2 vantage points on the Martian magnetosphere and letting them watch how the solar wind reshapes the environment on timescales of just a few minutes. To explain how all of this works and how ESCAPADE can finally tell us more about how Mars lost so much of its atmosphere, I'm joined by Dr. Rob Lillis, ESCAPADE Principal Investigator and Associate Director for Planetary Science at UC Berkeley's Space Science Laboratory. Hi, Rob. Welcome back to Planetary Radio.
Hi, Sarah. Good to see you.
Well, it's been 4 years since you spoke with my predecessor, Matt, about this mission. And in that time, your team has not only put together this mission, but a lot has changed in the moments in the interim. But Blue and Gold are now officially launched. What was it like to be there with the rest of your team, seeing this thing blast off in Florida?
It was exhilarating. It was anxious, as is true for any launch, but it was great to be with team members, family members, and a lot of people at Blue Origin who were also anxiously watching their second launch as well. And so it was really a great atmosphere at Blue Origin's Rocket Park headquarters in Merritt Island, Florida for that. So we had a clear view of the rocket as it was going up, and we were near the launch control room. So there was great celebration when the launch was successful, when the booster was recovered successfully, when the spacecraft separated. It was a very jubilant atmosphere, and it was followed by a champagne toast between Nikki Fox, Jeff Bezos, and Dave Limp to to celebrate the accomplishment.
Well, I was watching it from home, watching the live stream, and you could just feel the excitement of everybody there when this thing went up. There was so many new moments to this, not just this mission launching, but the success of the landing of that booster, along with the fact that this was the first real kind of science mission going up on the New Glenn rocket. And I had the privilege of being at that rocket factory, the Blue Origin rocket factory, when I went to go see the Artemis 1 launch. I got to be there with Bruce Batts to see that rocket in pieces on the floor. I can't even imagine how large that thing is in person.
The New Glenn, yes. We were also very privileged to get a launch pad tour on November 8th, the day before the first launch attempt. So we got to see the rocket all stacked up from just maybe 150 yards away. And we got to take lots of pictures with it. And it is very impressive up close. Yeah.
But you did have a few moments, weather scrubs, and also space weather delays during this time.
We sure did.
Yeah, what was that like, just emotion-wise, not knowing which day it was going to go up and having to return there repeatedly?
Yeah. Well, actually, I was there even a couple of days before that, because on Friday the 7th, we had a launch rehearsal where we went through all of the comms that would happen on the way to the countdown, et cetera. Then I was back at Blue Origin again Saturday the 8th for a press conference and also for the launch pad tour. And then we went back again for the first launch attempt on the 9th. And there were squalls of rain coming in. And the weather officer was saying, this isn't looking very good. So, and then also a cruise ship wandered into the launch box on Sunday as well. And we were like, what? How can that happen? And there were other fishing boats. And so there was just the launch on Sunday was, I don't know if cursed is the right word, but it just wasn't going to happen on Sunday. So then the wave heights were too high for a landing attempt, I believe, on the Monday and the Tuesday. And so Wednesday was going to be the next attempt. But then on Tuesday morning, we started seeing these big coronal mass ejections coming off the sun. And there were warnings that there was going to be a major space weather event on Earth. And so throughout Tuesday, we spent a lot of time looking carefully at the projections for the CME encounter with Earth, for it to impact Earth. And we spoke at length with some of the space weather people at the Moon to Mars Space Weather Analysis Office at Goddard, because these people, they work shifts until midnight every day, and their job is to analyze and predict potential space weather events. So between talking with those people, looking at the what's called SWPC or SWPC, this is the NOAA website that tracks space weather, we determined that not only was the level of charged particle radiation in Earth's radiation belts really, really elevated, like elevated by a factor of 1,000 from its baseline.
Wow.
And up to a level that was already too high. But then we saw that there was another coronal mass ejection shock due to strike Earth right at the time of what launch was going to be on Wednesday the 12th. And so we just said, look, our official recommendation is that we don't launch into this, because the nightmare scenario would have been when we deploy the spacecraft from the New Glenn upper stage. The solar arrays are supposed to autonomously deploy. There's a sequence that begins as soon as the spacecraft power up. But if you're in a radiation environment that's too harsh or hostile, and you're constantly getting spacecraft computer resets over and over again, there's a nightmare scenario where those panels just never deploy. And after 6 hours, the batteries are dead and your mission is over. And so we brought this up as an unacceptable risk. NASA were in full agreement with us. We walked through this with Blue Origin. They completely understood. And so launch was postponed until Thursday. And then, as you saw on Thursday the 13th, the launch went off. After there was a brief hold, it was meant to be 2:55. It ended up being 3:55, but it all went off great, 3:55. And everything after that was perfection. Everything went exactly as it was meant to.
It really did, though. I felt like a silly person in my apartment cheering at the top of my lungs, listening to the live stream, but it went off absolutely flawlessly, which after seeing what's happened with all of the other missions as part of the SIMPLEx program,
Yeah.
so many of them have gone through hardships. And
Yeah.
so far, this is the one truly successful part of the program. So I've just been rooting for you guys. It felt so cathartic to finally see those probes just launch out into space.
And not only that, it turns out that the injection Blue Origin gave us was so accurate that we can postpone our initial trajectory correction maneuver for several weeks because they gave us it was fractions of a sigma in terms of the accuracy. It was almost like that, famous the Ariane 5 that they gave to give JWST the perfect injection. It was like that. So, I mean, huge props to Blue Origin for building an amazing launch vehicle and giving us a perfect ride.
That's very useful in this case for several reasons. I mean, you were initially going to ride share with Rocket Lab's Photon, launching on Psyche, I believe, on a Falcon Heavy, and things have changed in the meantime. Now you're launching on a New Glenn.
Yeah, so actually, we did not start with Rocket Lab until after the decision to remove us from the Psyche mission occurred. That was in the fall of 2020.
Mm-hmm. But now, instead of launching within the normal launch windows to Mars, you're doing something very interesting, which is that you're going out to L2, you're going into this loiter orbit, and then you're going to be basically slingshotting around the Earth in order to get to Mars. So everything about this orbit is very different from the way that we usually launch to Mars. And I imagine having that extra accuracy, that extra fuel might really help as you try to pull this maneuver off.
That's exactly right. Yeah. So we have this kidney bean shaped so-called loiter orbit, which takes about 12 months. So we go up to about 3 or 4 million kilometers away from the Earth. We don't hang out at L2. We kind of go around L2 a couple of times, and we pass pretty close to the moon at one point as well. And then, yes, as you say, on November 7th, and then again on November 9th of next year, we will be coming down to a very low perigee, only 500 or 600 kilometers. We're going to be burning the engines at that point, taking advantage of that deep gravity well so that our burn is extra efficient, and we'll be slingshotting out into our interplanetary trajectory at that point to head off to Mars during that Hohmann transfer window during which an Earth to Mars ballistic trajectory is possible.
And this is just harkening me back to my Kerbal Space Program days, but pulling off an Oberth maneuver in order to try to get to Mars is so clever. And it occurs to me that we've been locked into this 26-month period of launching to Mars because of these limited launch windows, because of these planets and their positions relative to each other. But because you guys face this hardship, you had to figure out how to get to Mars outside of that window. Now you've opened up an entirely new way for us to think about these launch timings.
Yeah.
And perhaps even make a scenario in which we can save a lot of fuel when we're trying to launch these places by leveraging the Earth's gravity. It feels like this is such a clever way to go about this and could completely change the paradigm on Mars launches and even launches to other worlds even further out. Yeah,
that's right. They say necessity is the mother of invention, and that's exactly what we had to do. We had to come up with a way to get to Mars that was flexible, and we worked together with our partners at Advanced Space LLC in Westminster, Colorado, to come up with this design. And it's a flexible design because based on the exact size and shape of this kidney bean shaped orbit, we could have launched as early as May 2025 and as late as March 2026 and still been able to execute this circuitous path around L2 a couple of times back to do this Oberth maneuver without the date of that Oberth maneuver ever changing. It was always locked November 7th and 9th of next year. And yeah, this does open up a brand new way to think about sending payloads to Mars because, Earth only has so many launch pads. And if you have to launch everything that you want to send to Mars within one launch window, that launch window might only be 3 or 4 weeks long. There could be weather delays, hurricanes, etc. If you want to send dozens or hundreds of things to Mars, would be necessary for the human settlement of Mars in the future, you can't really do it all within that narrow window. But you could launch over the course of many, many months and kind of queue them up so that they could come in and do their Oberth maneuvers and slingshot their way onto their interplanetary trajectory, one after another, boom, 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 boom. And that way you could send a sort of an armada to Mars that you can launch over the course of 10 months instead of just one.
Well, these spacecraft are clearly designed to deal with space weather once they're actually out at Mars. But solar maximum is really popping off right now. Is there any concern that while you're out there at that loiter orbit, that these spacecraft could be any way damaged by some kind of CME while it's closer to Earth?
No, we're not really worried about that because we have a very robust fault protection system on board. They're very fault tolerant. Both we have redundant flight computers so that even if one resets and even if it latches up, we can always go flip over to the other one. So space weather doesn't bother us. We know what the total sort of radiation dose likelihood is over the course of this mission, taking account of all those CMEs, and we're confident that the shielding solution we have on board is going to handle that. The reason we were so worried about after launch was, as I just mentioned, when you're doing those really vulnerable early commissioning maneuvers to get yourself deployed solar panels, find the sun, and become stable and power positive. Doing that in the middle of a radiation storm was not something we wanted to do. But now there's no space weather event that we're afraid of now.
Well, now we're just counting down to next November, so these things can make their way to Mars. But once they get there, how are these two spacecraft going to be timed in their orbit around Mars so that they can get a better understanding of how the entire system interacts with the solar wind?
Before we get into our science orbit, we do have to be captured by Mars's gravity. So we got to do this Mars orbit insertion, and that's also fixed for September 7th and September 9th, 2027. We'll be captured into a large orbit, and then we will spend several months reducing the sizes of the orbits and then also synchronizing the orbits, because the arrangement of the two spacecraft in orbit around Mars has to be very precise to do the kind of science we want to do. In particular, we call it the string of pearls, or Science Campaign A, where the two spacecraft are essentially in the same orbit following each other. And it takes time to get into that orbit. And also there's a particularly long solar conjunction that occurs late in 2027 when the sun comes between Earth and Mars. And this is a particularly long one. So there's a whole month where we can't talk to the spacecraft. Anyway, once we get into 8, and we get into this string of pearls orbit, now we'll be set up so that we can really, for the first time, understand how Mars's upper atmosphere and its magnetosphere and near space environment varies on timescales of minutes, because those are the timescales that we know the system must actually vary on and respond to changes in the solar wind on. Whereas up until now, with only single spacecraft mission that could measure plasma parameters at Mars, such as Mars Express or MAVEN, you had to wait 4.5 hours before you came back to the same place in the atmosphere. And things can change a lot in the solar wind in 4.5 hours. So having the two spacecraft in this same orbit will allow us to say, okay, the conditions are X at this point, and say 3 minutes later, the conditions are now Y, or maybe they're still X. Maybe they haven't changed, or maybe they have. And that time separation between the two spacecraft, between the blue and gold probes, is going to be varying between 2 minutes and 30 minutes, back and forth. So their orbits are almost identical, but not quite, so that the relative positions in the orbit will slowly drift with respect to each other to give us a range of different time separations so we can really characterize the system on that range of different timescales.
We'll be right back with the rest of our celebration of the ESCAPADE launch after the short break.
Greetings, Bill Nye here, CEO of the Planetary Society. We are a community of people dedicated to the scientific exploration of space. We're explorers dedicated to making the future better for all humankind. Now, as the world's largest independent space organization, we are rallying public support for space exploration, making sure that there is real funding, especially for NASA science. Now, we've had some success during this challenging year, but along with advocacy, we have our STEP initiative and our Neo Shoemaker grants. So please support us. We want to finish 2025 strong and keep that momentum going into 2026. So check us out at planetary.org/planetary fund today. Thank you.
Well, you've worked not only on MAVEN, but also on the HOPE Mars orbiter, and now this mission. And each of these missions, in some part, is trying to contribute to this mystery of how Mars lost its atmosphere over time. So what have we learned from these previous missions, and how is this new spacecraft going to add on to that in such a way that we're going to learn things that we did not know before?
Okay, well, certainly the MAVEN spacecraft and the Mars Express spacecraft and the HOPE probe from the UAE have all contributed in their own way. MAVEN is still collecting very useful data on an atmospheric escape because this particular solar max is much larger than the previous one that MAVEN kind of arrived kind of at the end of and didn't really catch much of. So MAVEN is characterizing atmospheric escape at Mars at much higher solar activities than it has up until now. And MAVEN can characterize many different kinds of atmospheric escape, both the escape of oxygen, hydrogen in its neutral form, but then also in its ionized form. And the HOPE probe is able to see much larger distances away from Mars because it has this very, very long orbit, this 55-hour orbit. HOPE is able to see the extended oxygen, what's called corona or extended exosphere of Mars. And being able to see that far out lets us more accurately determine what the rate of oxygen escape rates are. So combining HOPE and MAVEN is really helping us to understand what I might call the kind of average state of atmospheric escape of Mars. Okay, what do I mean by average state? It's because when you only have one observation sort of platform or viewpoint at a time, you can say, okay, well, when the solar wind is at this particular speed, we see the ion escape rate at this particular level. But you got to wait 2 hours between when you measure the solar wind and when you measure the ion escape rate, because you can't be in two places at once. And HOPE cannot measure ion escape. It only measures neutral escape. But with ESCAPADE, we're going to be able to be in two places at once. And that's a good segue into describing our second science campaign, which is Science Campaign B, which is where the two orbits are now of different sizes, therefore different periods. We're at the end of Science Campaign A, we're going to raise the apoapsis, meaning the highest point in the orbit of one spacecraft, and lower the other one. So now with the two spacecraft in different period orbits, they will now be able to precess with respect to each other. This will allow the two spacecraft to be much further apart from each other so that we can simultaneously measure the upstream conditions and also the downstream conditions. So we can simultaneously see the cause and the effect at the same time. Whereas with earlier missions, we had to wait a couple hours. Whereas we know from all of our simulations, all the physics, we know that it should be changing on a timescale of a minute or two. So we'll have that ability to unravel that chain of cause and effect for the first time with ESCAPADE. And that's how it'll build on these earlier missions.
I think that was one of the things that you said in your conversation with Matt that blew my mind most. The fact that this entire system changes over the scale of minutes is absolutely mind-blowing when you think about it.
Yeah, that's right. And it's a consequence of the fact that the solar wind is moving at 400 kilometers per second. And so if you take, Mars itself, Mars has a radius of 3,400 kilometers. And even the area around Mars, it's not that big compared to a solar wind proton traveling that fast. So it only does take about a minute, 2 minutes for the effect of any particular solar disturbance to propagate through the system. Now, there's still some debate as to, well, is it quite that fast? How quickly does it take for the magnetic fields that are embedded within the ionosphere to completely turn around? That's probably more than a couple of minutes. It depends how deep you are in the ionosphere. There's something we call magnetic fossil fields, meaning that they kind of hang around longer and it takes longer for them to kind of to change. So there's a lot of unknowns there that ESCAPADE is going to start to be able to unravel, because up until now, it's just been kind of, simulations and one measurement every 4 hours. Now we're going to be able to have two measurements in quick succession, and that'll really help us unravel this highly dynamic, complex system that is the Mars upper atmosphere.
Well, Ari spoke with us a little bit about the VISIONS instrument and about the images that they're going to be taking from these spacecraft, but there are several other instruments on board. Can you tell us a little bit about what kind of instruments are on these probes in order to allow us to do this kind of study of the atmosphere?
Yeah, sure. So ESCAPADE's basic instrument suite consists of 4 instruments. The first is what we call a Langmuir probe. And this is actually 4 different sensors, which together measure what we call the thermal plasma. So this is the low energy, kind of what we say is cold plasma in the ionosphere. This is electrons and ions. We have separate sensors to measure the electrons. Those are these 4 little needles that are on our extendable deployable boom. Those needles measure the current from electrons, and that allows us to determine the electron density. We also have these little golden squares on the spacecraft deck called planar ion probes. And those collect currents from ions. And by measuring that current, we're able to determine the ion density. And then lastly, we have what's called a floating potential probe. It's this shiny golden sphere at the end of a stick. It's actually very distinctive. You'll notice a lot of the pictures in the media taken of the ESCAPADE probes in the clean room at Rocket Lab they were engineers looking at their own reflection in this little golden sphere. That measures the relative potential of the spacecraft, meaning the electrical potential. So we can see whether the spacecraft is charging up or charging down. That's important because if the spacecraft charges up and it's, let's say, electrically positive, that's going to affect how we measure ions and electrons, because those will be either repelled from or attracted to the spacecraft, depending on how charged up it is. So that the floating potential probe, or FPP, that's going to measure that. So that's the Langmuir probe. Our Langmuir probe was provided by Embry-Riddle Aeronautical University in Daytona Beach, Florida. So shout out to them, and Dr. Aro Barjatia, who's the instrument lead there. Okay, moving on to the magnetometer. It was provided by Goddard Space Flight Center. The PI is Dr. Jared Espley there. And Goddard make fantastic scientific magnetometers. They made the MAVEN magnetometer, and this is simply a miniature version of the MAVEN magnetometer. And it is at the end of our 2-meter deployable boom to get it as far away from those electrically noisy solar panels as possible in order to make the kind of really sensitive measurement of the magnetic fields that we see at Mars. And it needs to be not only sensitive, but needs to have a wide dynamic range, because it could see magnetic fields as little as half a nanotesla and as much as 1,000 nanoteslas. And so it's an instrument that's designed to operate in the Martian environment. Lastly, we have our 2 electrostatic analyzers. These are built here at the UC Berkeley Space Sciences Lab. And one of them measures higher energy electrons, and the other measures high energy ions. But as opposed to just measuring their densities, we need to measure their energy spectra and also their angular distribution. So these instruments have to be able to measure electrons or ions coming from all directions at all different energies. And it's a very ingenious design that was pioneered here at Berkeley in the early 80s and has evolved since in order to do that. And lastly, they can also measure the different masses of ions, because we want to know whether it's protons, whether it's helium, whether it's carbon, oxygen, oxygen-2, or CO2. So all those different masses of ions from mass 1 atomic mass unit up to 44 atomic mass units, we can distinguish all of those as well. So we can really tell not just that something is escaping from Mars, but what is escaping. Is it CO2? Is it oxygen? Is it carbon? So our instrument suite is going to be able to do that. And then, of course, as you mentioned, we have our cameras from Northern Arizona University. These are they have 2 lenses on each one. One is a visible camera, what you would pretty similar to what's in your cell phone, except obviously a very high quality charge coupled device, CCD, very sensitive device, and of course, ruggedized for space. And then separately, we have a microbolometer array to take infrared images as well. So both visible and infrared. And not only are we hoping to do a little bit of Mars surface science, for example, to determine things like surface temperature on Mars, but we're hoping to be able to see Martian aurora on the night side too. And the Perseverance rover was able to, for the first time earlier this year, image Martian aurora from the surface of Mars in the visible. And we have measured ultraviolet aurora from several spacecraft in orbit, but we've never measured visible aurora from orbit ever before. So we're hoping that the ESCAPADE cameras are sensitive enough to do that. Our calculations say they should be, but we won't know till we see it, and fingers crossed. But we're really excited to get this instrument suite in orbit around Mars to start doing the science that we need to do there.
Yeah, there's so much going on in Martian aurora science over the last few years that result from hope about the proton aurorae on the sun side of the world. It's absolutely mind-boggling. So I think between all of these different spacecraft together, we're going to get a much better not only picture of it mentally, but maybe actual pictures.
Yeah.
Oh,
Yeah.
that'd be so beautiful. But we have 2 spacecraft here.
Yes.
We're going to know a little bit more about what's going on in the locations where those spacecraft are. But using these 2 probes, can we then extrapolate out to the larger system of how, more broadly, I mean, it's not like there's a really strong global magnetosphere on Mars, but just the entire system and how it interacts with the solar wind. Are we going to be able to get a more 3D understanding of how that happens?
Yeah, certainly. As I mentioned earlier, just being able to have 2 measurements at the same time will enable us to build up a better idea of what Mars's 3D magnetosphere looks like at any one time. Of course, it's not the same as having 10 or 30 probes, but it's so much better than having 1. And speaking of 3D understanding of this dynamic system, we have 2 different types of global simulations. We have different team members who run different codes. One is called a magnetohydrodynamic code, and another one is called a hybrid code that deals with electrons as a fluid and ions as particles. And we have team members from France, from UCLA, who are going to be running those models. And those models are going to be really important context because we'll be able to at least say that, well, if the conditions where the 2 spacecraft are, if those are accurately reproduced by the models, we can be reasonably confident that the models are probably accurate elsewhere. Now, that's going to be true sometimes, but I guarantee you other times the models are not going to be able to capture the dynamic situation at Mars. And so we're hopefully going to be able to improve the models because the models aren't perfect either. There's a famous saying, all models are wrong, some models are useful. But those sorts of physics-based global simulations of the planet combined with our multi-point measurements will definitely enable us to get a much better 3D picture. And the reason I kind of stopped myself there was because I wanted to say it isn't just going to be ESCAPADE. We're going to have MAVEN as well. And it's almost like MAVEN is the big sister and ESCAPADE, Blue and Gold, are the 2 little brothers who are showing up to kind of, to take their place in what was increasingly becoming a Mars space weather constellation. And we additionally have the European Mars Express spacecraft still soldiering on 22 years later. And we're going to have another addition, which is the Japanese Mars Moons Explorer mission, MMX. It's going to be launching in late 2026, and it's going to be hanging around Mars's moon. Well, it's going to go to Deimos first, but it's going to actually sample Phobos, and it's going to be orbiting there. It's going to be measuring the solar wind and the magnetic field for about 3 years there, too. And lastly, we have China's Tianwen-1 probe as well, which is also measuring a magnetic field. And the Chinese scientists, they've been making their data public, and there's already publications showing up from scientists all over the world using data from both MAVEN and from Tianwen and from Mars Express. And so we're going to be adding 3 more spacecraft, both ESCAPADEs and Japan's MMX. So it's really it's going to be kind of a golden era of understanding of the Mars near space environment and how it responds to space weather.
Well, this is such an important part of the Martian kind of ecosystem that we need to understand better, not just because we want to know how it lost its atmosphere over time and its potential for habitability in the past, but there's so much discussion about potentially sending humans to Mars. And it's so important that we understand what's going on with the solar wind interactions there, because if we want our people in space to be safe, we need to have this kind of information, especially during solar maximum.
Yes, we sure do. And the data ESCAPADE is going to be collecting and the knowledge ESCAPADE will be contributing to are really relevant to the project of sending humans to Mars in a few different ways. I mean, one, we're going to have a multi-point additional pair of observations to understand how the solar wind interacts with Mars. We're going to be able to measure those high energy particles that can cause, human health concerns. And we're going to have just additional points in the solar system to understand how those big coronal mass ejection shocks that carry so much high energy particle radiation, how those propagate throughout the solar system. So we'll actually have the measurements ESCAPADE is going to make on the way to Mars, as well as the measurements that it makes at Mars. So that's from a kind of an astronaut health perspective, but we also have a communication issue as well. Because Mars has a very patchy ionosphere and a much less well understood ionosphere than Earth does. And when we want to navigate on Earth, when we want to use GPS, the GPS signals that we use in our phones on Earth are automatically corrected for ionospheric perturbations in a way that's totally invisible to us, the users, as we're holding our smartphone and we see that little blue dot, like correct within a couple meters usually. The reason that that's possible is because we understand how the ionosphere distorts those signals on Earth. And when we do have a big solar storm, the accuracy of GPS does tend to go down. Although, because we have good monitoring, we can keep track of how that distortion is changing. On Mars, we really don't have a good understanding of the variability of the ionosphere. So the ESCAPADEs passing through that ionosphere twice in quick succession during our campaign A is going to give us really our first kind of look at how the ionosphere changes on those timescales, and therefore will give us in the future an ability to accurately estimate how radio signals are distorted as they propagate through that ionosphere. And so that's important for navigation, but also just for communication too, particularly, if you want to use shortwave radio. Let's say you have two settlements on Mars that are a couple thousand kilometers apart. They want to talk to each other. You can use satellites. You can try to use the ionosphere to bounce the signals off as we do on Earth. So understanding the Mars ionosphere better is going to be really important for understanding how radio waves propagate for both communication and also for navigation.
Well, once these spacecraft actually reach Mars, how long are we expecting them to survive and be taking good data?
So NASA has approved an initial 11-month science campaign beginning in June 2028, going until May 2029. However, we have designed the spacecraft to last at least 5 years. So from launch, launch in 2025, so at least until late 2030. But spacecraft tend to have a habit of lasting longer than you planned because engineers are pretty conservative. And so just because our batteries might degrade a little bit more over time, we just got to be nicer to them. I mean, this is true for all aging spacecraft. Same thing is true for the solar panels. They're going to be a little bit less efficient, but that's just normal. That happens over time. And the fact that we have spacecraft like Mars Odyssey, which is over 100,000 orbits now. We have Mars Express, which is only a little younger than Odyssey. We got Mars Reconnaissance Orbiter, still mostly going strong. We're confident that Rocket Lab have built us a really good pair of probes. And if we can get them into Mars orbit, we're confident, though, they could last a very long time.
And on such a smaller budget compared to so many of these other missions, because you're part of the SIMPLEx program.
That's right.
If you guys pull this off, it is going to be paradigm changing.
Yeah, I think so. I think, if you take the costs of previous missions, they are about 10 times what ESCAPADE will have spent, at least on the spacecraft. And I know it's not exactly apples to apples. ESCAPADE's instruments were very high heritage and simple, and there were fewer of them compared to, for example, MRO or MAVEN. That being said, doing an entire mission, we at Berkeley and Rocket Lab, we delivered these two probes for the original launch attempt in fall 2024 for $49.3 million, which is about a tenth of what it would have cost doing it the usual way. And there were a few different reasons for that. One was that, as you said, the SIMPLEx program was meant to be a lower cost program where NASA exercises less oversight. NASA required far smaller amounts of documentation. There wasn't as many reviews where they have to go with a fine-tooth comb through all of your data to really be convinced that things are as you say they are. There's just more trust placed in the project team. NASA sort of says, we trust you. You're the experts. We'll still keep an eye on you, of course. We'll still have reviews, just not the same level of oversight as before. And the same was true for the launch contract, a so-called VADR, Venture Class Acquisition for Dedicated and Rideshare. This is another, I know it's a tortured acronym. This is another way in which NASA has procured lower cost launch vehicles too, with also less oversight than usual. And you should probably get someone from NASA's Launch Services Program in someday to go through what that has meant for the launch business. But then also, Rocket Lab, they operate under a firm fixed price, vertically integrated, off the shelf, commercial forward way of doing things, whereby they can just get things done for a much lower cost because they've embraced efficiency. They have far fewer subcontractors because they have just either learned how to do everything in-house or they've purchased these other companies to bring them in-house. And so they have a lot more control over their schedule when literally the people making the solar panels are also the same company. And one great example of where that really shone through was the fuel and oxidizer tanks during our development phase. They were being procured from a subcontractor, and that contractor was having difficulties. They had personnel issues, they had issues with their building, and they were falling really far behind. And we were getting really nervous. Us and NASA and also Rocket Lab were getting very nervous about these tanks being delivered on time for the original launch attempt in fall 2024. And Rocket Lab, they saw this and they said, we really need more control over this. So they spun up an effort to make the tanks in-house with their 3D printing technology. And they were able to essentially make the tanks in-house so as not to need this external vendor. And they did all that within just a few months. We were really, really impressed. I was quoted in the media last fall as saying that Rocket Lab went into so-called hero mode to go recover from that tanks issue. And it's just an example of where the new space companies like Rocket Lab can be more nimble, they can fix problems faster, and they can deliver a great product for a much lower price. And this is what's going to be, I think, greatly enabling for these sorts of missions in the future. You know, NASA's always going to need the big flagship missions to do the really, really hard things, and those are great. But I think a larger proportion of NASA's budget can go to a much larger number of lower cost missions. And this is something which the new NASA administrator nominee, Jared Isaacman, has said over and over again in his posts on Twitter, public remarks, etc. I had a chance to speak to him at the launch, and he said the same thing there. He's been consistent. And so hopefully we can get to a place where we're having more missions like ESCAPADE.
I would love to live in a future where we have probes around every single world in our solar system, and whatever kind of technology and funding process we need to go through in order to enable that, I'm here for it. So all the missions across the map, let's do it.
Absolutely. Yes. Yes. And, you know, look, I think fixating on a particular price point, like 100 million, that's definitely useful. There's a lot of great science you can do for $100 million. There's also plenty of science that you just need 200 or 300 million for. So every mission shouldn't be 100 million. There are certain things that are just harder and that are still, you know, very much worth doing that are at higher price points. But every mission can be done more efficiently than it is being done now.
Well, I want to say congratulations to you and the entire team for pulling this off. I've been so excited about this, in part because UC Berkeley was my alma mater. So knowing that there's knowing that there's going to be probes going around Mars named for the blue and gold makes me just personally very happy. But also, these are such deep questions that have huge implications for our future exploration, not just for probes, not just for our understanding of that world, but for the future of human exploration to Mars and across our solar system. So I'm just so looking forward to seeing what happens once these missions get there. And I would love to bring you back on once we know a little more about the atmosphere to actually piece apart some of the results, because I think it's going to be really interesting.
I would be delighted to come back in 2027 and talk to you some more about that.
Absolutely. Well, thank you so much, Rob.
Okay, thanks, Sarah.
Even though Mars doesn't have a global magnetic dynamo, it does have remnant crustal magnetic fields and an induced magnetosphere. This strange magnetic environment is what allows Mars to produce aurorae. They happen mostly on the night side, but sometimes they happen in unusual forms like proton aurorae on the day side. Dr. Bruce Betts, our chief scientist, is here to discuss in What's Up. Hey, Bruce.
Hello, Sarah.
I had a really fun time watching the ESCAPADE launch. Did you get a chance to watch that live stream?
No, I did not. I apologize. How'd it go? I mean, was it fabulous? Was it enjoyable? Did you love it?
I mean, honestly, I don't want to put it this way, but it went way better than I thought it would. Because it's only the second successful launch of the New Glenn rocket, and they absolutely nailed that landing. And that's a hard thing to accomplish, especially with all these other things going on. You know, you got solar storms, and I don't know. It was really thrilling after all of the delays. Plus, part of what this mission is going to be doing in order to learn more about the interaction between the solar wind and Mars is that they're going to be trying to look for aurorae on Mars. And as I was learning more about this, I learned from some data from some European missions, but also from the Emirates HOPE mission to Mars, that most of the aurora on Mars happen on the night side. Why is that?
Partying. Yeah, they party more at night. It's they're chilling hard. Okay, I'll stop.
That tracks.
It's complicated. Mars has only got remnant crustal magnetic field. So it has no global magnetic field. Once upon a time, it had magnetic field, and when the lavas were coming out, they froze the magnetic field in it. So there are these localized small magnetic fields, but overall you don't have one, and so things work very differently than on a planet like Earth or Jupiter or Saturn, most of the other places that have a strong internal magnetic field. So you actually end up with things that are a little different.
So how does the solar wind actually get around Mars and reach the night side?
So solar wind, the charged particles from the sun, can wrap around the planet and go party, as I told you it was party in the magnetotail, so the part that gets stretched out behind the planet of the magnetic field lines, and they're able to get in there and weasel their way in and abuse the atmosphere in somewhat different ways. I'm trying to use as much technical jargon as possible. Let me know if I lose you. And then those are the draped field lines, and they're the open field lines which connect Mars with space directly, kind of like your brain.
Right in the membrane. Like this is why you need the tinfoil hats, to block the.
I can neither confirm nor deny.
So basically, the electrons from the sun reach the magnetopause, and then they penetrate down into the atmosphere on the night side.
So the night side ionosphere is weaker than the day side ionosphere, so the electrons can go play lower down, and there's also less atmospheric fluff because the sun's UV is not hitting it, so it's not inflating the atmosphere. So they're even getting deeper down in the already thin atmosphere. And then the crustal magnetism has effects where you create hotspots and places where you concentrate things due to the very non-uniform magnetic field of the crust. So you end up seeing types of aurora as well, which are not something that we see elsewhere because of things like the effects of the crustal magnetism, the ionosphere, et cetera, et cetera, et cetera. Okay, so that having been said, we come back to the weird proton aurora where you can get day-side protons that are, solar wind is mostly protons, but then they do a little party with the hydrogen in Mars's upper atmosphere, and they become things that party down and make an aurora. Because on Mars you're not going to see it because of the sunlight overwhelming it, just like on Earth in the day side with our visible focused eyes.
Yeah, it was one of my favorite results that came out of the Emirates Mars mission, the HOPE probe, was learning more about the aurora on Mars and those really weird proton aurorae. Like I'd never heard of anything like that before. But each and every world's aurora is completely different. And it's strange to me that these aren't gathered around the poles. I mean, apart from the fact that I guess the strongest bit of magnetic field localized on Mars is near the South Pole, but that's not because of a global magnetosphere. Like, it's just weird that worlds that don't have a global magnetosphere can still have these effects.
It is weird. And you get, that's true basically of Venus as well. But there you get effects with interactions between the thick atmosphere and the solar wind. And solar wind, protons and things, they party their atmosphere, but they come in, they follow magnetic field lines, and they go usually party at the poles. And every once in a while you get coronal mass ejections like we did recently, where you can actually see them farther away from the poles. But usually they're being directed that way, but they're being directed by the global magnetic field that doesn't exist on Mars anymore.
I love that Ari pointed that out in the short conversation I had with him, that how funny it is that this mission that's trying to go to Mars to learn more about how solar storms interact with the atmosphere itself was completely delayed because of a solar storm. Like, the solar maximum's wild.
Whoa.
All right. So what's our random space fact this week?
Random space fact rewind. We're going far out of the solar system this time, to the land of super crazy. The gravity at the surface of a neutron star is more than 100 billion times the gravity at the surface of Earth. Dun, dun, dun. Freaky, man.
Of all the things I wish we could get images of up close, it would probably be a neutron star, because what even is going on there?
They are freaky weird.
Right? I mean, degenerate, matter.
What'd you call me? All right, everybody, go out there, look up the night sky, and think about your favorite degenerate object. Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with even more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Also, our holiday gift guide for space fans is out, so I'm going to link to it on this episode page, just in case you need it. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or, if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members all around the world. You can join us as we continue to advocate for even more missions to Mars and beyond at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, which we're going to be postponing for 1 week until December 12th. And Matt Kaplan hosts our monthly Book Club Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. My name is Sarah El-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.